Amazing. All right. Well, thank you everyone for coming here to Arthur's headquarters in what we often call Soho, but it's actually technically NoHo. Do not tell people it's Soho. We're here to be in, I think, the 5th or 6th iteration of Ground Truth. So Ground Truth is a series that we kicked off last year. They're conversations with experts in the AI/ML space, the policy space around that, researchers, practitioners, startup folks, and so on, often in the New York scene, although obviously as you see from the speakers here, not just from New York. So we're lucky today to have 2 panels back to back. They'll be somewhere in the 30 to 40 minute range each. The first panel nominally is going to look into building and selling task-specific large language models and large multimodal models. So this is an interesting discussion that says, hey, maybe you shouldn't use the foundation model to rule them all because it costs a lot and you don't control it, et cetera, et cetera, et cetera, although there are reasons to use that, obviously. We have some great speakers from Nomic, CKI, Abridge, CMU, JHU, and so on for this panel. The next panel will be about future directions, R&D and LLMs, LMMs, and AI/ML, and that'll have some experts more local here. So I'll be chatting there. We'll have some folks from Arthur, and then NYU, Genentech, and NYU from a postdoc of Jan Koons. So feel free to, well, actually don't feel free to during the actual panel ask questions. We'll have a Q&A after that, right? So we're going to try and have a Q&A there. Without further ado, I'd love to introduce Ben, who is our moderator for the first panel, and our panelists, who will introduce themselves.
All right, thanks everybody. Why don't we just start off by giving a quick introduction, everybody, of themselves. I think I've got your CVs here, but I suspect you are better at describing your most interesting features to everybody. So Raz Besaleli, would you mind starting off?
Is this turned on? Okay. My name is Raz Besaleli. I am the Director of AI Research at CKI. We build natural language interfaces for databases. I am also at Whiting at JHU in Systems Engineering Department.
Cool. Hi, everybody. My name is Zack. I've been losing my voice on and off, so apologize if I sound ridiculous. I'm a professor of machine learning at Carnegie Mellon, and I'm the Chief Technology Officer and Chief Scientist of Abridge. At Abridge, our mission is to kind of make it possible for doctors to practice medicine again. And we do that by leveraging the audio of doctor-patient conversations to take all the documentation burden off their plates.
Hi, everyone. My name is Andriy. I'm a founder and CTO at Nomic. Before Nomic, I was actually over here in New York, a PhD student at NYU, but I left out to work on Nomic. Basically, the whole idea behind what we work on is making AI systems more accessible and explainable to just like the average people out there. So just like, how do we as everyday humans in a world where there's 10 million documents of text, 10 million images, 10 million video snippets, interact with that scale of data, use it, and make decisions based off of it? We build tools and systems that sort of like work in that direction.
All right, so I want to kick us off by talking about evaluation in this space, because I know this is something all of 3 of you have thought about pretty heavily. In the last few years, sometimes it feels like the metrics that we use to evaluate the success of language models and other deep learning models have actually fallen behind the models themselves. Certainly in what we're talking about task-specific LLMs, you can't necessarily use general benchmarks, but nowadays people are often being pushed to use general purpose AI models for domain-specific problems. So how do you guys think about what makes for a good evaluation set? Where do you learn how to create evaluations? How do you evaluate whether you are succeeding in your domains when you train and deploy models?
I mean, I could start with a short point, which is I think one of the first things you learn how to do in research is to separate the definition of a problem from the form of a solution. Like if you've coupled what problem you're trying to solve to what is your way of going about it, then you've erred in some fundamental way where now it's hard to improve because you don't know where the problem statement ends and the solution begins. So I think it's important to come up with what are you trying to do in your specific domain and what are the things that are relevant to measure, and come up with a really comprehensive evaluation framework. The fact that a particular solution strategy happens to involve a general purpose model that, maybe you arrived at that via prompt engineering off of some general purpose LLM as opposed to parameter fitting based on supervised learning, I don't think should really matter. I think if you've done your job of modularizing, what am I trying to do and how do I measure it, then it shouldn't matter. It's just that it should be subjected to the same criteria as you would if you were training your model via supervised learning in a more familiar way.
Yeah, kind of specifically in the context of LLMs, usually when people are like, hey, what is the best model to use for the specific problem? Or you train your own model, how do I, evaluate it for a specific use case that I care about? It's really easy to just pick sort of the easy route and be like, oh, which number is higher on some random leaderboard you might find on some website like Hugging Face or something like this. And I just think this is one of the worst things to happen to all of NLP and all of just applied machine learning work in the past 2 or 3 years. Just the leaderboardization of just how these people think about evaluating these models, as it's a lot more nitty gritty than just numbers on a leaderboard. My stance is that everyone should be really, really focused not on building models, but building very good tech specific benchmarks that are internal to the specific use case, and then working back on the actual modeling once they've defined very clearly how they want to actually test their model in a sort of dev environment.
Yeah, I agree with this notion that the leaderboardization of these evaluations kind of is insufficient. When you're building a product, often the task that you're trying to solve is a lot broader than what these leaderboards do. So for example, in my space, we do a lot of text to SQL. The most popular benchmark there is the Spider leaderboard, if anyone has heard of it. What Spider does is very, very specific, actually. It does not measure the best text to SQL model. It measures how well a semantic parsing model can generalize to new databases in a text to SQL context. So when you have a company like Seek that's trying to build natural language interfaces for data, there's obviously a lot more that goes into than, oh, how well can my model generalize to new databases? There's all kinds of syntactic and semantic aspects that you should be doing. Not only should you have very task-specific benchmarks, but you should have a whole suite of them. Furthermore, when you build these systems in the real world, there's often a lot more than the model. I'm very adamant about the fact that a language model is specifically in a decoder context. When you have an autoregressive language model, the input is a sequence and the output is a set of log probabilities or logits of what token comes next. That is it. The autoregressive text generation algorithm that sits on top is not part of the model. If you have an RAG system set up to it, that's not a model. That's not part of the model either. Instead, you have an entire system encompassing the model, and that needs to be treated in its own right too. So it's not just a matter of how well this model does, whether it is in a metric as simple as perplexity, which has been a very, very old metric, as many of you may know. But you really need to be evaluating how are you using the model, especially if you're just taking a model from Cohere or OpenAI or something.
I don't know. So the biggest thing I would say on evaluation on my end is when you think about how do you evaluate an ML system, or how do you evaluate a specific, in this case, like an LLM that you've worked on for some specific use case that you've built, you should really be thinking back not to okay, here's my solution, here's the thing I want to get to. Think back to that very first day or first month and whenever you took a data science course or a machine learning course, and the same 5 steps you learned on how to evaluate a system back then are actually the same 5 steps you need to follow. Don't look at your eval set every time you're iterating on it. Look at your dev set. These are just small things that people just don't really seem to do anymore, but actually are just how you fundamentally say whether a single system in the that's learned statistics from data is able to outperform one or the other. And then obviously, if you're in application, you want to tie it back to a real problem that you're solving. For instance, maybe Zack has something to say about that.
Yeah, I mean, one thing that I can go into is I think since we're talking about LLMs, it's interesting thing about what's changed, and I think when I started my PhD, now I'm old, just me and Cho. Cho's a little bit older than me though. He's 2 years older than me. I think we're probably the same age. He's academic older than me. So when I started PhD, I think mostly it was kind of a sandbox discipline. Most of what was taking place was researchers doing work sort of for researchers. It was a very speculative discipline. and unless you worked in ads, in which case you were doing something. But and most of the tasks, like at least most of the kind of applied work had like discriminative type tasks, like regression tasks, classification tasks, and you had you could always get into the weeds of like maybe not all errors are equal, and maybe there's some kind of hidden cost sensitivity, and I care about different strata of the data. But for the most part, you had some reasonable criteria of like, I have a data set, this is the ground truth, this is what accuracy is. And then we started deploying models, and a lot of my research focused on this problem that once you deploy a model, it's like, when you talk about accuracy, like any statistic, like accuracy is contingent on a population. And if you're not deploying it in the exact same environment that produced your training data, then it's like what licenses you to think that you know anything about how your model performs, and under what circumstances, under what assumptions, and what commitments about how your training data is related to what you're seeing in production, can you stand by any kind of claims about performance? And that's still a problem. But now things have gotten even more complicated. I think what's changed in the so-called like generative AI era, we use the term kind of loosely, but I think one thing that we mean when we talk about generative AI is that we're talking about a lot of applications where the output of a model is not just a classification. It is not just even if you're producing your output by making a sequence of classification decisions and sampling from those probabilities, it's like at the end of the day, like the output of the model is like a media artifact. It's something like a document or something like an image. And there's no longer like an unambiguous, like clear notion of accuracy. So you have like many different dimensions of task fitness. And I point out even that maybe like the gentlest of the like generative tasks might have been like summarization, just generate a sentence in a target language, given one in a source language. And even there's some ambiguity over like, there's not just one universal, there's so much because of synonymy, there's not one universal correct translation for every sentence, but still you can get pretty far by saying if I have a reference data set of human generated translations, I could look at something like word overlap. Now when it comes to things like in the world that we're in, like for example, trying to generate a history of present illness associated with a particular doctor-patient interaction, there is not a reference data set that has exactly the like Platonic archetype of this is the perfect note. The perfect note is not what exists. What exists in the wild is what doctors are doing with very limited time and bandwidth and doing their best, but also so now we're in this world where like we're learning from all kinds of objectives, or all kinds of signal. And we're kind of often like hill climbing against these sort of like unknown objectives. You're producing something that like didn't already exist out there. And I think at this point, like we have to think very differently about evaluation. It's not just about like check, does prediction equal gold standard? We have to evolve like much more sophisticated processes that aren't just like, they're not just like a function call, but there's like a business process, something that's human in the loop. There's like judgments that need to be made about quality. For us to release anything into the wild, there's an evaluation process that has to involve ratings of quality of a proposed system against the status quo along a whole bunch of different known issues. It also has to be human eyes on things because there's unknown unknowns. There's things that you don't know to put in your questionnaire, but new problems that might crop up. So I think like the total surface area of evaluation and the number of aspects of quality that you're worrying about in this world of like so-called generative AI is like a formidable new frontier.
Yeah, I think that at the risk of sounding harsh, in these quote unquote generative tasks, if you're dealing with natural language and you're trying to do something even as simple as summarization, listen, like 5 years ago, summarization was like pick the sentences in the document that that are like the most important, and then you can just omit everything else. Now we've turned it into generating a sequence and paraphrasing, which is completely different, and no metric that you make will ever correlate exactly to your perceived performance of the model, because human judgment is arbitrary. It's always going to be arbitrary, and because we're only modeling like what words occur around other words. Like it's what words occur occur on other words don't necessarily capture like the semantic and pragmatic complexities in communication. I'm using communication in like in contrast to, you know, words in a sequence. So I think that we're going to start to see a lot more emphasis on things such as online learning, and people start to depart from, you know, I mean, I hope that people start departing from like, you know, blindly following benchmarks and saying this is the best model, because, you know, like it's kind of like BS. Like you can't just like optimize on a single metric and expect it to account for something as complex and structured as natural language.
I can give an anecdote, but we can also move on to another section. But this kind of like riffs off on this a little bit. So one of my first sort of like lucky enough to get jobs where I ended up at the startup where we were doing abstractive summarization of radiology reports. We were like writing radiology reports with back then it wasn't called an LLM, now it is. And basically we'd summarize everything that the radiologist saw from the images into this section, which was like a conclusion. And the problem with that is, like, you know, all of us were all these machine learning engineers and we thought we were so smart. And it turns out like the metric that you're trying to evaluate for, it's like this qualitative metric, right? Just like how good does the human think that this like AI generated summary is? Like the ultimate metric is like, is this replacing the mental load I have, the radiologist has in like doing their job? And like we basically like from square one had to figure out, okay, well, the expensive option is we hire a bunch of radiologists, make the model generate stuff, and have them, you know, sitting there at $400 an hour clicking like upvote, downvote. And then like obviously you need a cheaper option for that. And this is where like this whole idea of like how do you build good qualitative metrics for models comes into play. It's extremely hard. What we actually ended up doing is like, I think one of the very first solutions that we implemented was pulling out like medical concepts from the target summary, pulling out medical concepts from the generated summary, and doing simple things like Jaccard's like similarities, like intersection over union. And that was like one of the best metrics that correlated with like humans actually saying this actually included all the right like clinical things coming out. So it's like you can't think of things like accuracy as kind of useful now, when you're in this situation.
Yeah, just a really quick follow-up. We do a lot of very similar things, and it's, I think one difference in this space is like, right, like you don't even have the pretense that you're going to come up with some one metric to rule them all. What you're trying to build is like when you're generating something that is like free text, it's a sort of organic object. You're trying to build something like a sensory apparatus. Like I want to have a bunch of different measurements, all of which are taken with a grain of salt, but you know, none of which is necessarily like one thing to rule them all. But a degradation in anyone is something that warrants further investigation. I'll give an example. Is we do something similar, pulling medical concepts out of an underlying transcript, pulling medical concepts out of a generated summary.
It's the obvious.
And you have some, right? And now it's an interesting thing because like you don't actually want to have perfect recall. Right? Like if the patient's a hypochondriac and they come in and they're like, doctor, do I have cancer? And doc's like, no, you don't have cancer. You don't want the note to then be like, you know, in your problem list, cancer. So optimizing for like a recall of one is not, you know, necessarily where you want to go. But on the other hand, if you go from one system to another and like the recall dips from, you know, like 60 to 40 or something, then maybe you should look deeper and make sure that you didn't fuck everything up.
Yeah, I just remember like we were flying blind. Like we would ship a model and then ship the next model. Half the users get really happy. Other users would be like, what the hell just happened? I mean, you see this nowadays when like GPT-4 ships a new model. Some people are like, wow, this is great. And then the other half are just like, you broke my whole entire production environment. What the hell? We're switching right now. Yeah, it was important.
So I'm sort of interested in how you're talking about the way that the leaderboardization has taken over this field in the period where this field has become commercialized or unmoored in certain ways from its academic roots. Like, and you know, we've got selling right on the big board right there is the thing that we're talking about. How does selling relate to evaluation here? Like one of the things that both of you are talking about is you have to go to people and convince people that you've got the best model. And so that might be saying we win on this metric. Or it might be hoping that the people that you're in a meeting with have the absolute like see it immediately and understand that you've got the best results. Like if you're not persuading people with metrics that you've got a better model, how do you get, not how do you evaluate, but how do your buyers, how do your sales prospects evaluate, and how do how good a job do they do? Are people doing the right job when they're evaluating things by typing a couple things into a box, or are they not doing a good job right now and people are not actually getting the best models that they could for their money?
Well, no one said that metrics are bad, and no one said that selling on metrics are bad. I think that selling on recall, for example, is not the best probably. I think that more of the progressive approaches is looking at like other heuristic metrics. So you know, in text-to-SQL as our sample application, you know, you can look at the like Levenstein distance between your generated query and like whatever, and like the actual one. You can look at like execution accuracy. You can look at all like you can look at like how many columns did you get correct, how many statements or like how many like clauses in the SQL did you get correct. But like, okay, first of all, the problem is bigger than text-to-SQL because it turns out that business users who are asking questions about their data often don't know what they want to ask. So it's like difficult to like say, oh, this model is like really effective, and then someone asks like a really, really vague and silly question, like what is our revenue? I mean, anyone who's in business knows like, okay, that's a really, really broad question. Like, please. So I think that like I think that if you take more of like a human-computer interaction approach and look at like how much time does the model save you if you use it in the system that you've implemented it in, how much happier are your customers? Are they spending more time on your like basic, very, very basic product KPIs are often enough indicator to tell you whether you're doing the right thing. In systems engineering, we have a we have a like a if anyone's heard of MOPs versus MOEs, you have we make this distinction between measures of performance and measures of effectiveness. Measures of performance influence, or they kind of describe how well the product you have built works, and the measure of effectiveness measures kind of like how, like whether you've built the right product, right? People are often more convinced by saying, oh, X product will save you Y time, than we have a bajillion % like recall or blue score or like whatever. People, I mean, like people like big numbers, so I mean, like they don't actually care like what the number represents.
This is actually a problem that's very near and dear to my heart as somebody out there trying to like sell an AI product to people every day and sitting in sales calls and like dealing with this every day. How do you convince like a random business executive somewhere in the stack of 5,000 people that like your system is useful or important? Honestly, like these people are smart. They're not going to like make a decision based off of, you know, some metric being high or something. It boils down to like you solving a real problem for them, whatever that problem your solution solves. So leaderboards is a way to like maybe get your face in front of them, but like the number on the leaderboard, they don't give two flying whatevers about what what that number says.
Yeah, I mean, you know, depending on what domain you're in, there may or may not even exist a common leaderboard. You know, like in our case, we have like a massive data set of medical conversations for developing the speech portion of our technology. It's not something that any of our competitors have the exact same data set or apples numbers. So I don't know that like I'm as affected by like leaderboard myopia, just being in a very like specific area where we have to develop the data resources that even make it possible in the first place. There's a lot of different things that you measure in this world, and I think just jumping on a point that Roz made, like there are a lot of different things that people care about and that maybe carry the story at different stages. You know, when you're first speaking to someone, I think, you know, they do care about knowing like overall on kind of generic like corpora in your domain, what is the word error rate? What is the word error rate specifically on medical terms? What is the performance of the system on medical terms that were added to the vocabulary after the cutoff date, like new medication names? Like apparently everyone and their mother are taking Ozempic right now, but that didn't exist. Yeah, can I get a Wegovy? So for people to know what are the performance characteristics of the system, or like we have a feature where you highlight any span of text in the summary and you float over to exactly where is the substantiating evidence in the underlying transcript. What fraction of the times when such evidence exists do you find it? But then like that gets you to a point of something like initiating a pilot. When someone goes from a pilot to like, we actually want an enterprise-wide license, they care about things like how much time are the doctors spending in aggregate in the electronic health record every day? How much time are they spending after 7 p.m. and before 7 a.m.? It's something that we call pajama time. So doctors now these days, actually, they go home and they see their family and then they go back into the electronic health record and try to finish up their paperwork. So what fraction of the final note was ultimately written, what fraction of what you generated was actually useful versus like sort of what was the edit distance to get from there to the final note that the doctor signed? How much work did they still have to do? How big is the residual? And that kind of thing, those like outcome focused metrics, I think are ultimately, what carries the day for as in like any service that you would provide.
All right, I want to change directions here for a second and talk about openness and open source technology, because this is like historically one of the benefits of science is that it strives for reproducible, openly distributed results, but also if you're sitting on a data set, as you mentioned, that can be one of your business's primary resources. Certainly we've seen that there are a lot of companies that are not necessarily open sourcing all of the research in a way that they used to. And I'm just curious, like, what value does open source have nowadays in this field? What kind of fealty do you feel like you owe to that? Or is it,
Can I just push back on the premise first?
Yeah, please.
Like, cool, just to make it,
No.
Yeah, Right, spicier. That's why they asked me on panels.
No fealty.
I just want to push back that, like, look, I think there's a question of, like, do you have a commitment to the open source community? Are you contributing back? And now, arguably, open source is under a certain kind of threat right now with some of the discourse about like, is the AGI getting too dangerous and maybe we shouldn't have these tools in the open. You see some discussion on the Hill that's going after open source in an existential way that I think we haven't seen before in our lifetimes. But I also want to push back that open source and supporting the open source community and like private sector has never corresponded one-to-one to sharing, for example, like all of your private data. In fact, I think that's a big part of how like Google and Facebook have sort of like justified their the things that they have open source in the past is sort of like, hey, like we're in a position to realize the value of this technology in a way that no one else is, because at least within our domains, because we sit on this giant monopoly over, say, search or over social media, and we have the data, and other people who don't have the data won't be able to use the models to do the things that we could do. So it's never been an all or nothing proposition where companies have like either said we're sharing everything that we have in this world with absolutely everyone, or we're not doing anything. I think there's always been people having some proprietary models, people having massive amounts of proprietary data that they either don't for business strategic reasons or can't due to privacy reasons share, and at the same time have I think you could have a healthy relationship where you contribute back to the scientific community.
Yeah, I also I don't really know how much of a choice we have. A couple instances in recent history come to mind. Who remembers when Llama came out and like the next day, like someone posted a torrent on the GitHub for the weights? Like people will always do that. I think that if, like after 50 years of computer stuff, we might be able to come to that conclusion. Additionally, there's a lot of work on black hat adversarial stuff, where people are getting models to regurgitate their training data or whatever prompt they're using or so on and so forth. And honestly, I think it's only a matter of time before someone comes up with a methodology to just figure out all the training data for like, I mean, if you like, let's say that you have like a pre-trained model. I mean, what do you have to as far as like pre-training goes, like what choices do you have? Like you have like C4, the pile, and maybe like a few others. Like I feel like it wouldn't be that hard to figure out which one it was. Of course, this is like a very generic case. I think that a lot of how to put it. I'm gonna stop there for right now.
Okay, I think you got to wrap up now.
Yeah, I want to ask one last question before we go, which is just we're still in January here. So I want to ask the three of you, like, what are you looking forward to in 2024? Like, is there, I know some of you are at NeurIPS, like seeing the papers, thinking about what's going to come on the horizon. Like, in this field, what are the developments that you're most excited about?
Not LLMs.
Are these developments that we're excited about, or developments that we think are going to happen that we're excited about?
The development that isn't going to happen is. But take your pick.
I'm excited for people to. Okay, so there's been a lot. If anyone here was at NeurIPS, there was a lot of talk about alternatives to transformers, namely Mamba, monarch matrices, hyena, so on and so forth. I'm really excited for people to realize that maybe variations in architectures for determining the distribution of word forms still like lies under a bottleneck where it's like you can only do so much with looking at patterns of like surface representations. Whether this is going to happen, I have no idea. But hopefully we can see some bigger changes in our methodologies than just trying to model things purely distributionally.
I think that's us.
Or Zack.
You gotta look forward to something. 2024.
Oh, okay, good. I mean, I said not LLMs.
That was your.
I think like having models with more interesting inductive biases that solve problems that aren't generating text and all the cool things that LLMs can do when you train them on a lot of text is like really interesting. Like AI for science is like, I guess, the theme of this whole day. And there's just so many problems that are like really, really important that honestly don't have industry applications yet, but maybe in 10 years will, that I think this like current generation of systems allows. And like, I just don't want to go to another NeurIPS where everyone's talking about LLMs, basically.
That's what ACL is for.
Yeah.
Stay out of my lane.
I'd love to thank the moderator and all of the panelists for their opinions. Some fact, some waiting to be seen if they're fact. So we're going to keep going through to the second panel, which will keep sort of tightly coupled to the schedule that we have. Obviously, if you want to pop up and grab a drink or whatever, do so as you will. But I'd love to introduce Teresa Dada, who will be the moderator for the next panel. So Teresa is a MLE here at Arthur and has done a lot of great work both on the practical and the applied and the sort of theoretical side of various forms of responsible AI. So, Teresa.
Thanks, everybody. Welcome to part 2 of AI Crashes the Science Party. Also, a little note, we love our office space at Arthur. However, the rear of the room, the sound does tend to carry, even in whispers. So just asking you to be mindful as we continue with our second panel. I would love to introduce Micah Goldblum, Kyunghyun, Cho, and John Dickerson, as we all know. Perfect. Okay, awesome. Thank you. All right. Thanks, everybody, for joining us. So thanks, John, for introducing me. My name is Teresa. I'm one of the machine learning engineers here at Arthur. Really passionate about trust and transparency in algorithmic systems. And I'd love, I guess, to kick us off to hear a little bit about each of our panelists. Introduce yourselves, talk a little bit about your background in AI and STEM, whatever you'd like to share today. Micah?
Cool. Yeah, I'm Micah. I'm a postdoc at NYU down the street, and I work on AI safety and just trying to understand how and why neural networks work.
Oh, hi, I'm Kyunghyun. I'm a professor of computer science and data science at NYU. I'm in the same building with Micah. I've been working on a variety of stuff, but generally anything that has something to do with the machine learning algorithms and the properties of the various algorithms in the context of the difficult problems such as natural language processing, machine translation, physics, and computational biology and whatnot. And at the same time, I also hold the position of the Senior Director of Frontier Research at Prescient Design of the Genentech, which is a Roche company. And then there, we actually work on how to build what we call lab-in-the-loop machine learning molecular design platform using a variety of the paradigms from machine learning, including active learning, generative modeling, as well as a multi-objective black box optimization. Well, it's great to be here.
And I'm John Dickerson, so I'm on leave from a professorship at the University of Maryland, where I worked primarily in market design, the design of systems that might have strategic agents trying to manipulate things. And this has become a little bit hotter now as agents are now sort of in the common press. Reasoning is becoming a common thing. We have Q-star rumors, if you want to believe any of that. And I'm also a chief scientist and co-founder here at Arthur. So many of you have been to Arthur before, but again, thank you for popping by.
Awesome. Thanks, everybody. Okay, so on the note of AI and science, I think it'd be really great to kick us off on thinking about how improvements and progress in foundation models can help to transform research and science and other industries. And Kyunghyun, I'd love to hear a little bit more about your work at Genentech, where I believe you focus on drug discovery and other biological processes. Love to hear more.
So if somebody actually tackles me, that's going to be Genentech comms team. I never told them I was going to be here, but so so don't be alarmed. That's kind of anticipated. So in a way, unlike, let's say, solving one problem that is right in front of you, that is well specified, when it comes to, let's say, discovery process, that is that we want to discover a new molecule that's going to become a new drug, that's going to treat conditions that we didn't know how to treat before. It actually is not really about, here's one question, let's get the answer. It's really about, here's a gigantic space that is often combinatorial, so the size of the space grows exponentially with respect to the size of the things that we're looking for. And in this exponential space, how do we actually efficiently and effectively search or make a small let's say, search steps over and over until we find the good one? Now, what that means is that we do need a lot of different machine learning paradigms, but also at the same time, what really makes it difficult is that we don't know what is the right solution. Let's say somebody gave you on a paper, right? You're talking about the NeurIPS. You go to a NeurIPS, you see all those machine learning for molecular design papers, and then they said, okay, here's an amazing molecule that's generated by the diffusion-based model. Let's say I gave you this. And then will you be able to tell me how awesome or amazing the molecule is going to be for the, let's say, particular disease? Absolutely no one can do that. Actually, 0% can do that. And it's going to take anywhere between 5 to 50 years for us to even tell whether that is a good thing or not. Why is that? Because we actually don't know what are things that actually matter for the clinical outcomes. And then in order to figure that out, what we need is that we need a machine learning system that is able to see the heterogeneous sources of the data coming not only out of the labs, not only out of the scientific publication, not only out of the, some of the data that we have collected, but from every single stage of the, drug discovery, including clinical trials or how it actually works in the clinics. And then we heard a lot about the healthcare earlier, all those data collected from the EHR. But we actually haven't had, until recently, any machine learning model that is able to scale to this diverse set of the data sources as well as this amount of the data. And then that's where this kind of foundation model or this kind of language models or just a large-scale models have a huge potential for, is that it really allows us to make a bridge across all those different stages of the drug discovery or any kind of discovery stage so that we can now back propagate the final outcome all the way to the very first stage of the design or the discovery. So it's actually a really, really exciting time, in fact, for this kind of scientific discovery applications.
Yeah, truly. I did my undergraduate in organic chemistry, and so it's really interesting to look back on the professors who I used to work with and how they've been able to incorporate AI models into their workflows and how that's helped to expedite and change the game of sorts. Okay, cool. Kind of flipping gears a little bit, but one research topic that has really been pertinent in my brain recently that I've been really interested in is in detecting generated content, and something specifically called watermarking or bookmarking. Micah, I'd love if you could maybe explain those concepts to anybody who isn't quite familiar with them, and then maybe talk a little bit about your work in this space.
Yeah, so I think motivating this whole line of work is a fear that a lot of people have that as more and more of the content online is generated content, generated by machines and not by humans, we'll be inundated with this sort of content. Someone could make, millions of fake Twitter users, generate in an automated fashion tons and tons of fake news, and can really change people's opinions about real topics, can form social movements, political movements, can sway elections. And so how do we preempt this? How do we decide, how do we figure out what data or what text online, say, is generated by machines and what's generated by humans? And so one of the ways that people are trying to do this is by embedding patterns in the data. So, if OpenAI decides that on all of their API models, they're going to have some sampling procedure. So when they sample text, there will be some detectable patterns in the text that it generates. Then, we can just look at some generated text, maybe a tweet, maybe a news article, and we can say, oh, that contains this same pattern. It must be generated. And so people work on, how to make these watermarks, these patterns in the text more robust to, removal attempts, paraphrasing, and then other people try to work on breaking them. But I think there's a fundamental problem, which is that as time goes on, open source models are going to have become really, really good, and you're not going to be able to force all language models to be watermarked. And so I think it's a losing battle in the same way that if anyone wants to go and stream or download a TV show illegally, you can just do it. You don't need to know how to clone a GitHub repo or how to code. And I think as language models become more and more important, you're going to be able to use open source language models. And this is already happening without any know-how whatsoever. So I think that to some extent, watermarking is a lost cause for that application. But you can watermark the same way we watermark images for stock photos and stuff, and the way artists embed watermarks in their art that they post online as advertising. You can do the same thing for text. And one of the interesting things is you can do this without changing the quality of the text at all. You'd think that by embedding some noticeable pattern, the fact that it's noticeable means that you have to degrade the quality of your text, but you actually don't have to change the distribution that you're sampling from at all. But so, if you want to detect all the news or whatever that's generated by machines, maybe you can do it without watermarking. Watermarking makes it much easier, but if people are going to use the open source models, then it's a lost cause. But so one of the things that we're working on now is just, can you tell the difference between human-generated and machine-generated text? And it's a much, much harder problem, but in the last year or so, the community has made a lot of progress there.
Can I do a quick follow-up there? Just because I know you've worked a lot in adversarial machine learning as well, which I would argue is still not solved. The attackers are still winning entirely there. And this is maybe a form of adversarial machine learning.
Not necessarily in text, though.
Okay, sure, yeah. When it comes to, let's say that I have a large compute budget, I'm a nation state, and I want to create a model that is, it's going to be harder to detect using. I know you all have a paper that just came out recently. Can't I read that and then train against that? And as we iterate forward, do you think we're just going to follow the same path we followed in adversarial ML, where the attackers are always in the lead and there's really no evidence that the defenders are going to win?
Yeah, I think that so one of the constant themes in attack and defense sort of stuff is the question, does the attacker get the last move or does the defender get the last move? And if you generate, say I have some metric and then you game that metric by figuring out a way to generate text that is undetectable according to that metric, I look at your text and now that becomes part of my new research paper, I figure out a new way, and now your text is out there online and I just apply my new research metric to it. And this is a problem that has plagued a lot of security areas, in AI is that often one side gets the last move, but a lot of the research papers are sort of pretending as if they get the last move when they don't.
So another thing that you can imagine is that of course, it's always going to be a play between, let's say, adversary and then defender. And then what you can imagine is that, you can say that, okay, it's going to be a finite number of steps, and then one of them is going to have the final say. Of course, they're going to have the advantage there. But one way to avoid that is to actually just introduce the clear separation in terms of, let's say, computation complexity that is necessary in order to, for instance, embed a watermark versus a verification versus, in fact, the removal of the watermark. And then that's exactly the idea of the encryption and the cryptography, in a sense, is that we're not saying that we will be able to, let's say, add a watermark that is impossible to remove, because you will always be able to actually remove it automatically at some point. However, removal requires exponential time as opposed to linear time to add or to verify whether the watermark is there or not. So in that sense, I don't think it's necessary that we need to worry about whether the defender is going to have the final say or the attacker is going to have the final say, but more like what are the fundamental gap that we can create between verification and the removal, so that it doesn't really matter, assuming some reasonable resources, available resources, it really doesn't matter who actually has the final say.
Yeah, and I think another point to make there is that a lot of what makes attacks or defenses difficult is often not like a fundamental property. It's often the information that the attacker or the defender has. And so, some API model might have something going on behind the scenes that does something either to, for example, to prevent jailbreaking or for whatever other threat. And it's hard to bypass because we just don't know what it is. And when someone does bypass it, they'll switch it, they'll change the system to something a little bit different, and it will take people a while longer to bypass it, and then they'll switch it. And this is the way things work all the time. In the sort of adversarial space, it's much, much harder to make something fundamentally robust so that it's like theoretically impossible to break than it is to just have some defense that no one knows what it is, and then it's just hard to break.
Definitely. Okay, fascinating discussion. And I know a lot of this language, specifically around our previous topic of watermarking and detecting generated inputs, was actually included in President Biden's executive order, which was released last fall. I'm curious if we have any thoughts around the language that was utilized there, or any other thoughts about the language that's incorporated in the executive order.
I mean, it'll be interesting, right? If we've heard a lot of opinions here, right? And this is another sort of theory you hear floating around a lot, which is that the combination of some of the traditional watermarking techniques with crypto or with techniques from like zero knowledge proofs, things like that, will really push this forward. But in the case where watermarking is impossible in matters where it matters, or open source models come out and we can't detect them, then I don't know what you do with an executive order that asks you to do something that's impossible, right? And so the language there, I think, much like the language throughout I'm not making normative statements about this, right? Like, some people think it's paternalistic regulation. Some people think it didn't go too far enough. I think it's hard to argue that there's going to be no regulation in this space. Like, certainly there's going to be some regulation in this space. And so I think we should all be actively involved in talking about it. But I think there's a lot of language in there that's saying just kind of wishful thinking, right? Like, it's a brand new space. And I think watermarking is probably the best example of this in the EO. But like, putting limits on like the number of bits or parameters in a model is another sort of like kind of question mark there. We're going to see how they age. So I'm going to say, like, we'll see how the vibes are in 5 years on those. Yeah.
So one of the things that this executive order that you probably have read, or at least read the summary of, it wasn't actually about setting up the actual rules or the frameworks that we're going to follow. It was actually more about addressing or ordering all the federal agencies to come together and then come up with the answers to various questions that the executive branch has to answer, and then trying to use the answer based on which to inform the Congress to act on. Because at the end of the day, executive branch, what's their job? Their job is to execute whatever they were told to do by the Congress, right? And then the interesting thing here I want to point out is that when we think about this kind of attack defense kind of scenario, we often, our mind as a computer scientist, a lot of us, go almost directly to the point where we want to build a system that actually works without any trust. we hope to not have to rely on some kind of trust on the entities. And then that's one of the reasons why we all love the blockchain technology and so on, right? So can we have a triple ledger that is all public and without having essentially any kind of, let's say, trust or the organization that actually has the trust of all the players. But of course, in reality, federal government and then all those, let's say, executive, let's say, branches that we have built are actually the places that we have decided to, as a society, collectively put the trust. And then the question here is that yes, watermarking is absolutely not perfect. That's clear. And you all fly around and then you watch the movie. There's if it's a delta, there's a DL, right? And that's a watermarking. And then no one really cares about it, but we do it because there is a bit of a trust that, okay, if somebody's cool with that, then we're going to know that it was via the delta. So some of the movie studios will be able to go after delta for the leak of the information or the breach of the trust. So in a sense, the executive order was actually good in the sense that it was asking questions to all those federal agencies. I feel like the duration they were given, all those agencies, they're about 180 days to at most, let's say 2 years, may have been too short. And then maybe they are going to be rushed to come up with an immature solution.
They also weren't allocated resources, as far as I know, in the EO, right? And so you have this chicken and egg problem between Congress, people who give you money, and then being able to make your case that you need money or should have money. So, yeah.
Yes,
Okay,
Teresa, go ahead.
awesome.
Yes.
Yes. So, on the note of the executive order, I know that there's a lot of language around concepts of responsibility, transparency, safety. I'm curious what that means to each of you. What are kind of the most pertinent responsible AI concerns for you in 2024?
Yeah, I think that a lot of the people in research who work on like safety, security, bias, these sorts of things in language models are people who came from a background doing this in other sorts of models before language models. And I think a lot of the things that we're working on are just not necessarily the biggest threats, the biggest safety risks when it comes to language models. And I think a lot of the biggest risks, in my mind, at least for language models, is using them for things that they're just not that good at. It's not a malicious actor who's trying to use them to do something really bad, trying to get OpenAI's models to say bad words or something like that, which is what, there are tons of papers going up on arXiv every day doing that. But I think, we're using our models, they're trained to generate text, but we're using them for so many things beyond that. And so many of these things, they're just not well equipped to do. So, for instance, if we use models to do decision making, say we're using models to give legal advice or financial advice or to do medical diagnosis, these decisions that we make using these models have costs associated with them. And if you want to assess your risk, traditionally, if you had a model that was telling you to do things, maybe it was a classifier and it had a probability associated to each class. But now we don't even know the probabilities, the confidence that our models have in their predictions, because they don't really output meaningful confidences corresponding to their predictions at a concept level. They give you, the probability of a sequence of tokens, but it might be able to phrase the sequence or the concept there a billion different ways. So we just don't know what the probability is, and we have no way of assessing risk using those models. It's just one example of the many ways in which we're poorly equipped to use these models to do a lot of the things that we're using them to do.
Great. So if I'm hearing you correctly, it's kind of about overgeneralized usage of these large language models and kind of promoting use case specific paradigms that entail confidence scores and other use case specific necessities.
Yeah, and I think a lot of that is going to be coming up with better ways of knowing how appropriate our models are for the tasks at hand too.
Yeah. So I mean, of course, I totally agree with Micah in the sense that those things are going to be issues, and that those are already issues in some sense. Those misuses by the users of these technologies that have just been deployed widely. But that aside, one thing that I see really somewhat disappointing, especially during the past, let's say, year and a half or so, based on what the policymakers as well as the executive branches have been doing, is that they are all just bringing in all these the amazing startup founders, the tech founders or the tech leaders, and then ask them what they should do, and then what kind of risks or the issues that we're going to run into by widely deploying these technologies. I don't know if you noticed, in one of the Senate hearings, there was Sam Altman sitting there, and then there was Gary Marcus. I was like, I don't know why he was there to start with, but and then I think Ms. Montgomery was there as well from the IBM, if I recall correctly. And then what you see as missing in many of these conversations, or the closer session that Chuck Schumer, at this center of this state, opened, was that they never actually invite over the people who are either using it or are being subjected to these technologies that are being very rapidly deployed at the moment. And then, in fact, who these policymakers or the representatives who are supposed to represent either the state or the individual citizens of the US, what they should listen to is actually us who are using it, who are being subjected to it. And then they are never being invited over. Now, there are a few cases in the, let's say, whole country where this kind of few, let's say, aspects of the regulation that where we have learned the lessons earlier on, so that we always bring in some of the people who are being subjected to the technology or the new let's say, ways of, let's say, deploying stuff. And then one of the examples is, let's say, FDA and NIH. We almost always, when we try to bring the drug through, or they approve the drug, they are always going to bring in the patient advocates, for instance. In the case of NIH, when they actually try to approve the grant, eventually the panel is going to include some of those patients or the people's advocate who are sitting there, who may not have actually zero idea about the actual technology, but who are representing at least some part of the people who are going to be subjected to this technology should it actually be implemented. So that's the part that I see as the biggest risk, is actually risk to everyone other than those who are here, actually.
I think that's a really great point, and it really touches on, who has the power to have a say and who is invited to kind of sit in the room where the decisions are being made. John?
Yeah, I think these are two beautiful answers, and I actually think this is a whole is greater than the sum of its parts moment, in the sense that if you get everybody in the room who can shape, in this case, regulation, including where you shouldn't regulate, right? Like, we as a country, we as a world, but we as a country should be very cognizant of over-regulation as well. But get everybody in the room that you should, let's say you do that, without being able to evaluate the efficacy of models, evaluate risk, et cetera. Like, most of these regulations come out with some sort of quantitative thing in them, or when they're, argued on the legal level, there's some numbers that float around, or some estimate of risk or probability or something like that floats away, right? So if you can decide on those numbers correctly because you have the right folks in the room, you still need to be able to measure those numbers, estimate those numbers, and so on. And so you can't really have one without the other. And I think Gen AI in general is really forcing us to think about both, because evaluation is so hard.
Definitely. And I recognize that it's been a long night for our audience. We have one final question, and then I definitely want to open up the floor to any questions that you all may have. So I'll leave this as a little look ahead to prepare any questions that you might have in mind. So our last kind of round robin quick question. So it's January 2024. Think 3 years from now, so 2027. What is the wildest dream that you see of how this field can be evolving in the next 3 years?
I think that in the future, we're going to move towards more and more multimodal models, and with more and more modalities, humans learn language not just from language. We learn from images, for example. Like, I could describe, if I push something hard, it tends to fall down, but I can learn that concept through images, and we have so many more gigabytes of data through video and images than we do through text. And we should be leveraging all of this sort of data, all of this information in our models, even if you only want to interface with a model through language or through one modality. There's so much we can learn from others. And I think in the future, we're going to move away from talking about large language models, and we're going to be talking about multimodal models.
I have an extremely high confidence prediction for 2027. Micah is going to be so busy building up his lab as a third-year assistant professor and also preparing the third-year review material. And I can guarantee that that's going to happen.
I'll double down on that, because I think we're going to have sensing, acting, reasoning, and learning. So we're going to have agents that do things. And so Micah won't have to do that. He'll have an agent that's doing it for him. But more seriously, I'm really excited about the agent sort of revolution that is happening. I mean, for many of us who've been in computer science for a very long time, the word agent has, it's not new. There have been funding cycles that push for it, and then there have been winters around this as well. But every one of these, we push a little bit closer to something that's pretty practical. And so, optimistically, Micah, hopefully you won't have to write that 3-year review.
Seems like there's lots of predictions for Micah's future. Well, thank you so much. I'd love to open up the floor to any questions that anybody might have. Yeah,
also to the previous panelist as well.
Thanks. My question is around the fact that we all kind of agree the sentiment that evaluation is very hard. We don't get the probabilities of the different things except just the tokens. So in the previous panel, at least, there was this notion that we can use human in the loop to assess on different tasks that the foundation model or LLMs are doing. Are there some design patterns, or what are you guys seeing as the emerging trend, even for 2024, to build specific tasks and evaluate on those for these large language models and deploy them with more care than just misusing them for doing way more than what they actually can do?
I can take a first stab at this. The first thing that comes to mind, and it's actually pretty interesting to see. This is an unclassified presentation, but US DoD has sort of a centralized thinking agency. They used to be called JAIC, called CDAO, which I forget what it stands for. But they have a great presentation on how USG basically is thinking about the evaluation of, they say LLM constantly, but they really mean, pick your favorite, whatever LLM, Gen AI system. And they're very, very explicit about we shouldn't be, I think I'm echoing Roz and every other panelist here, right? You can't just watch one metric or 10 metrics or 1,000 metrics on a single model. It's got to be the greater system. They actually have some very nice frameworks in there, not fully fleshed out, right? Because they're pushing for putting money into companies, agencies, contractors, and so on to figure this out. But they have some nice initial thoughts there. And so the thing to look up there, it's called Project Lima. And it's from the CDAO, and so I think this is going to actually shape, because they have a lot of money. The USG has a lot of money. They're going to shape what this looks like in the coming year.
So what is actually really exciting about this Gen AI or the foundation models or whatnot, in my opinion, is because they have a chance for us to solve a problem that we don't know how to even tell whether the answers are correct. So relying on the human evaluation, and in particular in en masse, is a very limited, not even a first step, half a step into deploying these advanced systems and benefiting from them. At the end of the day, true benefit that we're going to see will be from problems that we didn't even know that we could even tell whether the answers were correct or not. Yes.
Yeah, I'm actually optimistic about the direction evaluation has been going. I remember when I started doing deep learning, everyone was doing computer vision, and there was one metric, and that was ImageNet accuracy. And so you had thousands of models, and every model you could distill how good it is into one number. And now we have hundreds of benchmarks and a small number of language models. So we've moved from many models to very few metrics to tons of metrics to very few models. And I think it's a good shift in paradigm. And I think this is going to continue to change and improve.
Any other questions? Bill.
So, talking about going to multimodal models. Sure. Thinking about going to multimodal models. One of the questions I'd love to get your thought on is the equivalent of attention, or figuring out how to pay attention to the right things. I mean, if you think personal health thing, well, not only do you have the doctor's records, you have all the data from the person's watch and what other metrics. You have radiology pictures, all their drug dosage. I mean, when you start talking about multimodal, it's no longer just a sequence of text and we have the attention model. If you're really talking about having models having a rich source of data, which in our data-intensive world, there's going to be so much data in many modes that could be used. Finding the right data to draw conclusions from seems like a huge problem. And I'd love to have your thoughts about how do you extract the right multimodal data from all the data sources that will be available.
Yeah. So I think my hunch and my hope is that it's a problem that we're going to push back to whatever like self-supervision or supervision strategy we use during learning, and we'll let the model learn, you know, what to pay attention to in an end-to-end way, and we hopefully don't have to handcraft or even really put our own intuition into the system and can let it learn itself. So my hunch is that all the difficulty in training multimodal models will be to figure out the right self-supervision strategy to squeeze as much juice out of the data as we can.
I mean, it actually connects to the evaluation issues very well, in a sense that what is the right data, right? And then the right data is the data that is going to be useful eventually for us to build a system, or letting machine learning algorithm build a system that's going to do well on however the evaluation metric we are going to use, or however we are going to deploy them. So what that actually tells us is that we have to start thinking about the distinction between the noise or the biases that can be overcome automatically based on the types of the algorithms we make, and then the things that just cannot go away. And then, of course, cannot go away part is going to be an issue. That's where, I think that your question is more about is that, okay, so if there are things that are genuinely confusing because that is not the thing that algorithms can actually remove or resolve, then what can we do? But I believe that a lot of the data that we run into in reality is completely filled up with the first type of the noise that I'm pretty sure we'll be able to come up with a better algorithm with a better, so that they are going to be reduced as much as we want it to be. And then only later on, we're going to have an issue of the second type of the noise. So I'm optimistic as well, just like Micah. Yes.
Thanks. Hey, thanks for the presentation. My question's on responsible AI. It seems like there's two tracks of people, one of whom are pushing the imaginative boundaries of like what we can build, and the others who are holding true that we should do that responsibly. How do you guys contend with like the power struggles between these two groups, as like both are kind of racing ahead, and where do you sort of see these conflicts existing, and how can we sort of solve them? I guess that's a three-parter.
I can start by saying, like, we're not going to solve that on this panel for sure. But harkening back to a comment I made earlier, regardless of what you feel about regulation, and I think a lot of us here are probably tech optimists because we're in tech, and I think the majority of people in tech are tech optimists, but to be a realist, again, there's going to be regulation in this space, and so, like, I don't see a world where that doesn't happen. This is top of mind for everybody. This is top of mind for senators and Congress people now, C-suite where the C is not CTO or CIO. Like, something's going to happen here. And so it's more important, I would say, to be a realist and to make sure the right people are in the room, that we're not having regulatory capture in a bad way, but that we're also not over-regulating in a way that really kills competition.
Yeah, I actually don't see these two forces being as juxtaposed as they used to be. I think that actually in practice right now, capabilities research is aligned in many situations with safety, in the sense that a lot of what I see as shortcomings of our models or risks of them are associated to them with them doing things poorly. Or you can see in like RLHF, in alignment sort of research is actually improving the instruction following abilities, the capabilities of our models. And so I think there's actually a lot of incentive for people who are doing research and building new models to make them safer.
So answer is almost always at the middle, and then that is actually the reason why in this kind of democratic country it takes a long time for anything to be set in stone. And then even after that, there's going to be a number of challenges. And then we get a really wrong, let's say, view of how regulations are created and imposed. And then if you just read some of the articles from the last year, it looks like Sam Altman is going to do this, and then suddenly there's going to be regulation that's going to be imposed on the entire industry, but that's not how it works. And then in fact, in reality, what's going to happen is that there are existing legal frameworks, existing regulatory frameworks, they're going to be all challenged or tested, and then over time, many years, if not a couple of the decades, we will arrive at something which will still not be set in the stone because there will be constant stream of the challenges, both legal as well as based on the executive orders or whatnot, right? So in that sense, this kind of, let's say, extreme views only exists at the beginning before people actually start acting on creating any of these legal framework, the regulatory frameworks. It will automatically converge toward a midpoint somewhere. Now, of course, sometimes it's going to be closer to one than the other, but eventually somewhere there's much more reasonable. That's how I believe it's going to happen.
I'll also provide a quick plug, which is that we just wrapped up a project interviewing about 16 different stakeholders as to how members of the second group that you mentioned, people who might care about responsibility in AI and limiting the pace of innovation, might exist in companies which maybe don't, and what levers they may have access to increase corporate responsibility prioritization. So obviously we talked a lot about regulation here, and that is a huge motivator for companies to reprioritize or change their prioritization of responsibility. But there's also factors like customer demand. Customers can come to a business and specifically call out requests for certain types of audits. There's also journalism, socio-technical scholars that all play different roles. So happy to chat a little bit about this more after. Yes, but thank you so much, John, Kyunghyun, Micah. And also thank you to Arthur's marketing staff for putting this all together, and the Arthur headquarters. Thank you, Christina. Thank you, Sabrina. Thank you, Joe.
Thank you, Teresa.
Yes. All right, have a great evening.